Good day, sir. My name is Heldrin Elegino from BSCpE-1A, and today I'm going to solve the problem number 1 that which is assigned to us to solve it into implicit differentiation and higher order derivatives. So the question or the problem number 1 is x squared minus xy plus y squared is equals to e minus x, and find the dy over dx. So as you can see in the first variable, we see that there has an exponent. So I apply the power rule of differentiation, which has the n x raised to n minus 1. So it will become 2x 2 minus 1. So we will write this 2x 2 minus 1. So the second variable, I apply the product rule of differentiation that has a rule or formula of u dv plus b du. So in that case, while x is u and y is b. So the u is x and the derivative of y is 1, and dy over dx. So I put dy over dx because we are finding the derivative of y with respect of derivative of x, plus our b is y, derivative of u is 1. So it will become x dy over dx plus y times 1 is equals to y. So like this, x dy over dx plus y. So the third one of the variable is y squared. So we need to apply again the power rule of differentiation, which is nx raised to n minus 1. So it will become 2y 2 minus 1 and dy over dx. So I put dy over dx because we derive the y. So the third one, the last one, e raised to negative x. So I use the chain rule of exponential function, which is the formula of e raised to u times u prime. So it will become e raised to negative x times u prime with its negative 1. So it becomes to negative e raised to negative x. So I don't put the 1 because already intended it has the value of 1. So negative e raised to x. So now what we are going to do? So we can now execute or manipulate this one. So it becomes 2x raised to 2 minus 1 is equals to 1. So we don't need to put that. So negative times x dy over dx is equals to negative x dy over dx, and negative times positive y is equals to negative y, because any number that we multiply to negative is equal, it will become 2 negative. And plus 2y minus 2 raised to minus 1 is equals to 2y dy over dx is equals to negative dx. So, what we're going to do next? So, we're solving the implicit differentiation. So, we need to transpose into the left side the value or the number that has dy over dx and transpose into the right side that has no dy over dx. So, it will become negative x dy over dx plus 2y dy over dx and equals to e minus x. So transpose, it will become negative 2x. Transpose the negative y, it will become positive y. So, become dy over dx negative x plus 2y is equals to e minus x minus 2x plus 4. So, in this case, what we are going to do? Since we are finding the dy over dx, we need to divide both of them with negative x plus 2y so that we can cancel out this. Negative x plus 2y. So the remaining term will be dy over dx is equals to negative e x negative 2x plus y. Negative x plus 2y. So to simplify this, we need to cancel the common sign or the same sign. Cancel the negative sign. So the answer is dy over dx is equals to e raised to negative x negative 2x plus y over x plus 2y. So the answer of number 1, which is the problem of x squared minus xy plus y squared is equals e minus x, is dy over dx is equals to e raised to x minus 2x plus y over x plus 2y. So this is the answer of question or the problem number 1. So now we are now in the number 2 question with the sine x squared y is equals to g, and find the second derivative of y with respect of second derivative of x, where g is Earth gravitational acceleration. So first, we need to find the derivative of sine function, which is cosine u times u prime. So, to find the u prime, we need to find the product rule of x squared y, which is u is x squared and b is y. So in this case, we need to apply the product rule of differentiation with the u dv plus b So in that case, we need to run x squared. Derivative of b is 1 dy over dx. So I put dy over dx because we derived the value of y with respect of x. Plus our b is y there, and the derivative of u is 2x. So answer will be x squared dy over dx plus 2xy. So the cosine x squared y times x squared dy over dx plus 2xy, then x squared dy over dx cosine x squared y plus 2xy cosine x squared y. So since we are solving the number 2 problem into implicit differentiation, we need to transpose into the left side the value that has a dy over dx, and transpose to the right side the value of the numbers that has no dy over dx. So it will come to dy over dx x squared cosine x squared y, then cosine x squared y is equals to negative 2xy cosine x squared y. So it will become negative because I transpose it into the right side. So to solve this one, so that it will remain dy over dx, we need to divide both of them with the x squared cosine x squared y and x squared cosine x squared y. So cancel out the common term or common factor. So the remaining term will be dy over dx is equals to negative 2x y cosine x squared y x squared over cosine x squared y. So in this case, we can also cancel out this because it has common factor, common numerator, common denominator. Cancel. So the remaining dy over dx will be negative 2x and x squared. So what we are going to do? So we can also simplify this into simpler. So it will become dy over dx. Cancel the common variable. So the remaining will be negative 2y and x. 2y. So now we're going to proceed to, so this is our first derivative. So we're going now to our second derivative. So the second derivative of y over the respect of second derivative of x, which is negative 2y over x. So what we're going to do next? So we need to apply the quotient rule of differentiation which is this is the u and this is the v, with the formula of v du minus u dv over v squared. So v is x, and our derivative of u is negative 2 dy over dx. So I put dy over dx because we derived the u. So minus, then derivative of v is 1 over x squared. So x times u equals to negative 2x dy over dx. So negative then equals to positive 2y over x squared. So the second derivative of y dx squared equals to negative 2x dy over dx plus 2y over x squared. So what we are going to do next, so substitute the value of dy over dx. So it will become excuse me, it will become negative 2x dy negative 2y and x plus 2y over x squared. So in this case, we need to cancel this because it has the same variable, and it will become the second derivative of y with respect of second derivative of x. Negative 2 times 2 will be 4y plus 2y x squared. So the second derivative of y over the second derivative of x will be 6y plus 2y over x squared. So the second derivative of our y over the respect of the second derivative of x will be 6y plus 2y over x squared. So this is the answer of number 2. Thank you.